All right, I want to take a look again at exponential functions now that we have the chain rule, because there's several things we can do. First of all, if we have something like this, right, f of x equals e to the 2x, right, and I want to look at the derivative, f prime of x equals what? Well, I know how to take the derivative of e to the x, but this isn't e to the x, this is e to the something else. So sometimes I think of it like this. This is e to the u, where u is equal to 2x. So how do I take the derivative? Well, I got to take the derivative of e e to the u with respect to u first of all. The derivative of e to the u with respect to u is just e to the u, and then multiply by the derivative of u with respect to x. Right? Derivative of u with respect to x here is 2. So I've got e to the u, but u is 2x, times the derivative of u with respect to x, and that's just 2. So the derivative of e to the 2x is 2e to the 2x. Essentially, I've taken the derivative of the outside function, leaving the inside alone. To take the derivative of e to the x, you don't do anything. It's just e to the x. So there's the derivative of the outside function, leaving the inside alone. But then I multiply by the derivative of the inside. And the inside function here is 2x, and its derivative is 2, sitting right there. Okay. So the derivative of e to the 2x is 2e to the 2x. Okay. If I had something like, g of x equals e to the x squared plus 5x plus 7, then what's the derivative? Well, take the derivative of an exponential function, leaving the inside alone. Well, it's really easy to take the derivative of e to a power. It's just e to the same power. But then multiply by the derivative of that power. That's the inside function. Where did that 4 come from? E squared plus 5x plus 7. Right? So I end up with, I'm going to write this part first here, 2x plus 5 times e to the x squared plus 5x plus 7. So with an exponential function, the inside function is whatever's up in that exponent. Now, that being said, if we go back and look at all exponential functions, so if I have f of x equals a to the x, right? When I was looking at how to take these derivatives back in section 3.1, I ended up with that f prime of x was a to the x times some limit, right? The limit as h goes to 0 of e to the h minus 1 over h or something like that, right? I couldn't figure out what that was necessarily. Well, now we can, because what we can do is this. Whoa, come on now. F of x is, I'm going to rewrite a to the x as the following. E to the natural log of a to the x. Now, it may seem kind of funny to do this at first, but essentially it's like saying square it and square root it. I know I got a positive number here, so if I square it and square root it, I'm back to the same number. Well, I'm saying take the natural log and then exponentiate. That these are inverse functions of each other, they undo. But what I can do here is I can use a property of log and say now that f of x is e to the x times natural log a. That is, log of a to a power is the power can come out in front as a multiplier. Okay. So now I don't have a to the x, I have e to a power. Well, I like e to a power. I know how to take the derivative of e to a power. The derivative of e to the power is e to that same power times the derivative of the power. Right? Just like we did up here. Instead of it as an x squared plus 5x plus 7, it's an x times natural log of a. So this e to the x natural log a is the same as the a to the x there. But then what's the derivative of x times natural log a? Well, a is just some number. It's a constant. So this is a constant times x. How do you take the derivative of a constant times x? It's just the constant. The derivative of x natural log a with respect to x is just natural log a, whatever that number is. So notice we did the derivative of 2 to the x should be 2 to the x times the natural log of 2. Well, the natural log of 2 is, let me grab my calculator real quick here, natural log of 2 is 0.693. So this is 2 to the x times 0.693. Isn't that what we had when we did it back in section 3.1? Something like that. Likewise, the derivative of 3 to the x should be 3 to the x times the natural log of 3. Natural log of 3 is, I think, 1.1 something. No, it's 3 to the x times 1.098. So practically 1.1. And one last one, the derivative of e to the x should be e to the x times the natural log of e, but the natural log of e is 1, and so you just get e to the x. Okay? So anyway, now we can see what this limit is. The limit as h goes to 0 of, I hate it when this happens. I get all the way down the bottom and I find out that I made a mistake at the top. This was an a right here. A to the h minus 1 over h. You probably caught that. You're saying, Will, you know, you got a mistake here. Yeah. So the limit of 2 to the h minus 1 over h as h goes to 0 is 0.693. That's the log of 2, natural log of 2. The limit of 3 to the h minus 1 over h as h goes to 0 is the natural log of 3. And in particular, or in general, whatever, the limit as h goes to 0 of a to the h minus 1 over h is the natural log of a. Okay. So anyway, that was kind of a loose end that we had from section 3.1, but now that we have the chain rule, we can fill that in and figure out what that limit is.